Welcome to Conspiracist. Today we're diving into a pretty persistent idea, one that keeps popping up.
Mhm.
The hypothesis that governments have found evidence of anti-gravity, maybe even developed the technology, but have deliberately kept it hidden.
Yeah, it's a big one. And it pulls in threads from, fundamental physics, potential tech revolutions, and that whole question of what might be kept from the public eye.
Exactly. So our mission today is to really look closely, objectively at the claims, the reasoning behind them, based on the information that's out there.
Okay, so first things first,
Mhm.
we need to try and define anti-gravity. What are we even talking about here?
Good point. Because from a physics standpoint,
Right, if we take Einstein's general relativity as our best model, which it currently is, gravity isn't a force like, say, magnetism.
it's that space-time curvature idea.
Exactly. Mass and energy warp spacetime. And that warping is what we experience as gravity.
So anti-gravity might not mean a simple repulsive force, like magnets pushing apart.
Probably not. It might imply a way to somehow cancel out that curvature, or maybe sidestep its effects entirely.
Or maybe more simply, in some contexts, it just means lifting off the ground without any visible or, easily understandable means of propulsion.
That's often the core of it in these discussions, yeah. Overcoming gravity in unexplained ways.
And this idea that it's possible but secret often comes through stories, anecdotes, claims of suppressed inventions.
Like the Die Glock story.
Right, the Nazi bell theory. Supposedly this bell-shaped thing.
With counter-rotating cylinders inside.
Yeah, filled with some weird purplish radioactive stuff. Zerum 525, they call it.
The story goes it had anti-gravity effects. And there are claims about scientists involved dying mysteriously, the device being moved somewhere secret after the war.
And that concrete ring structure, the henge. Some people link it, maybe as a test rig.
But we have to say, there are strong counter-arguments, like the henge just being a mundane cooling tower base.
Yeah, the whole Die Glock narrative is, well, pretty far-fetched for many. It strains credibility.
Then there's electrogravitics.
Ah, the Biefeld-Brown effect.
Exactly. You take an asymmetrical capacitor, pump high voltage through it, and it produces a little bit of thrust. It's a real effect.
But the standard explanation is...
Ion wind.
Yeah.
Basically, the high voltage ionizes the air, and the movement of those charged air particles creates the thrust. It's conventional physics.
This is so not anti-gravity.
The consensus is no. Some people, like Byron Price, were quite critical, suggesting it was engineers maybe not fully grasping the physics. He called it a science without a single specimen.
Meaning no real proof beyond the known electrical effect.
Pretty much. And then you get more modern claims, things like propellantless propulsion.
Like Exodus propulsion technologies. They've talked about electromagnetic drives.
Yeah, suggesting, incredible travel times. Moon in under 3 hours, Mars in 5 or 6 days.
Which sounds amazing, but...
But the details on how it supposedly works are scarce, largely unknown to the public, which fuels speculation.
Okay, so we have these claims, these stories, but let's ground ourselves back in the science. General relativity.
It's our most successful theory of gravity. It works incredibly well, tested from solar system scales right up to cosmology.
And within that framework, manipulating gravity isn't like flipping a switch locally, is it?
No, probably not. If you could significantly alter gravity or space-time curvature in one place, you'd expect, well, potentially global consequences. It's the fabric of space-time itself you'd be messing with.
There are concepts like the energy momentum pseudotensor.
Right, which try to quantify the energy stored in the gravitational field in space-time. It hints at enormous amounts of energy being involved.
So fundamentally altering gravity would be a huge deal, energetically and structurally for the universe.
A very huge deal. Now, that said, scientists do explore alternatives to general relativity.
But not necessarily looking for anti-gravity in the conspiracy sense.
Not usually, no. It's more about trying to explain observations differently or unify theories. You have things like scalar field theories, biometric theories.
Which use more than one way to measure space-time geometry.
Essentially, yes. Then various tensor theories like Starobinski, Gauss-Bonnet, FIR gravity, scalar tensor theories, vector tensor theories, even non-metric theories.
That's a lot of different approaches.
It is. Some are maybe less favored now, sort of straw man theories used for comparison, but others are well motivated. They try to explain things like dark matter or dark energy without needing those exotic components.
Like MOND, Modified Newtonian dynamics, but the relativistic versions.
Exactly. Relativistic MOND, or TFS, the tensor vector scalar theory, are examples trying to explain galaxy rotation curves without dark matter.
And there are models trying to explain cosmic acceleration without dark energy, too.
Yes, things like the GRSI model, general relativity self-interaction. The idea is maybe gravity behaves slightly differently on very large scales due to its own energy.
But all these alternatives, they face serious testing, right?
Oh, absolutely. They have to be self-consistent mathematically. They need to be complete theories. They must reproduce all the successes of Newton's gravity and special relativity where those apply.
The classic tests. Bending of light, Mercury's orbit.
All of those. Plus, adherence to the Einstein equivalence principle, fitting the parametric post-Newtonian formalism, which parameterizes deviations from GR.
And now we have gravitational wave observations.
Crucial. Any alternative has to match those observations from merging black holes and neutron stars and cosmological tests how the universe evolves.
It's a tough gauntlet for any new theory.
Extremely tough. And interestingly, some of these alternatives, like certain vector tensor theories, can be designed so they look almost exactly like general relativity under most conditions.
Which makes them really hard to disprove experimentally.
Very difficult. You need specific extreme conditions or incredibly precise measurements to see a potential difference.
Okay, so back to the concealment idea. If anti-gravity were discovered, why hide it? What are the proposed motivations?
Well, the usual suspects in these kinds of theories. Maintaining power, military advantage. Think of the implications for warfare or surveillance.
Economic control, too, right? It often ties into the free energy suppression idea. If you control energy, you control a lot.
That's a very common thread. But then you have to ask about feasibility. Could something this fundamental really be kept secret?
A breakthrough, changing our understanding of a fundamental force.
You'd expect hints, leaks, independent rediscovery. Science isn't usually done in just one hidden lab. The global scientific community is vast and interconnected. It seems difficult to completely suppress something so big.
And there's another point. Gravity is weak. Really weak.
Incredibly weak compared to electromagnetism. We're talking, what, 38 orders of magnitude difference?
So if you want a strategic advantage, wouldn't manipulating electromagnetism, which we already do extensively, be more practical than trying to wrestle with the weakest force in nature?
It's a valid question. Does the potential payoff from controlling gravity justify the immense difficulty, assuming it's even possible, and the challenge of keeping it secret?
When we look at past claims of revolutionary discoveries that turned out wrong, there's this idea of pathological science.
Right. The N-rays example is classic. Early 20th century, a French physicist claims a new radiation type.
And lots of other scientists confirmed it for a while.
They did. Papers were published, experiments described, but then it was shown rather elegantly by Robert Wood using a prism secretly removed from the apparatus that the effects weren't real.
It was experimenter bias. Seeing what they expected.
Essentially, yes. Psychological or physiological effects in the observer, not a physical phenomenon. It shows how easily even trained scientists can be fooled or fool themselves.
So applying that caution, why is anti-gravity often seen as pseudoscience by the mainstream?
Well, several reasons we've touched on. First, it generally clashes with general relativity, our best tested theory of gravity, which describes it as space-time curvature, not a force to be simply counteracted.
And the lack of solid evidence.
Critically, yes. There's no reproducible, verifiable, peer-reviewed evidence of controlled anti-gravity effects. Lots of claims, anecdotes, videos of lifting devices.
But often explainable by conventional physics like ion wind or aerodynamics.
Yes. Or just lacking enough detail for proper scrutiny. Then there's the theoretical side. To get repulsive gravity within known physics, you'd likely need negative mass.
Something that weighs less than nothing.
Right. Our standard model of particle physics doesn't include it. While it might be mathematically consistent in some equations, there's zero experimental evidence it exists.
And you can't ignore the company it keeps, often appearing in UFO lore.
It's frequently tied to claims about recovered alien technology, like the Aztec crash stories or Hangar 18, which are largely considered fictional or hoaxes.
Yeah.
That association doesn't help its scientific credibility.
It automatically puts it in a certain category for many people.
It does, which isn't fair if there were real physics there, but is the context we have.
What about recent actual experiments? Didn't CERN test gravity on antimatter?
Yes, they did. The Alpha H experiment at CERN managed to trap antihydrogen atoms and observe their behavior in Earth's gravitational field.
And the result?
They fall down. Just like regular matter, gravity pulls antimatter downward.
So that rules out the idea that antimatter has anti-gravity
It
properties.
strongly refutes the simplest version of that idea, yes. It's another win for Einstein's theory. Specifically, the equivalence principle suggesting gravity treats all forms of mass energy the same way.
Are they still looking closer, though?
Oh yeah. The goal now is much higher precision measurements to see if antimatter falls down with exactly the same acceleration as matter or if there's some tiny, tiny difference. But the basic, does it fall up or down? Question seems settled. It falls down.
Okay, one last point. Let's imagine, just hypothetically, someone could manipulate gravity. Does that automatically mean we get reactionless space drives?
Not necessarily. That's another leap. Some analyses suggest that even if you could warp space-time locally, doing so in a way that generates net thrust without expelling reaction mass might still violate fundamental conservation laws, like conservation of momentum.
So controlling gravity might be one thing, but using it to just push off against space-time itself, maybe not possible.
It's an open theoretical question, but certainly not a guaranteed outcome. It's important to distinguish manipulating gravity from other hypothetical concepts like, say, warp drives or manipulating inertia directly, which might operate under different theoretical principles.
Right. So quite a journey there. We've looked at the core hypothesis of concealed anti-gravity,
Examine the anecdotal claims like Dirac and electrogravitics.
compared them against our solid understanding of gravity via general relativity and the alternatives being tested.
Consider the motivations and, importantly, the feasibility of concealment.
Touched on why it's often viewed skeptically, the concept of pseudoscience, and recent experimental results like the CERN antimatter test.
And ultimately, while the idea of anti-gravity is powerful, especially in fiction, the current scientific consensus, based on available evidence and theory, doesn't support the notion that functional, proven anti-gravity technology exists and is being suppressed.
What we see is complex physics, ongoing research into gravity's deeper nature, rigorous testing of alternatives, and yes, the noise of unsubstantiated claims and misinterpretations.
Which really leads to a final thought, perhaps for you listening. When you encounter these kinds of extraordinary claims, whether it's anti-gravity or something else, how do you personally balance that innate excitement about potential breakthroughs with the absolute necessity of rigorous scientific scrutiny and of verifiable evidence? It's a crucial balancing act.
A perfect place to leave it. Thank you for joining us for this deep dive into the world of anti-gravity conjectures.
Thanks for listening to Conspiracist.